Okay, so derivatives of exponential functions, and we're going to go through our rules here. So, if our function has some base to the power of an exponent, that is a variable, then the derivative of this function is the derivative with the same exponent multiplied by ln of the base. And that's if our exponent is just x. If we run into a case where our function is equal to an exponential function where the base has an exponent of another function, then the derivative of that function is equal to what we started with, the base to that function, multiplied by ln of the base, then multiplied by the derivative of that function, the exponent, okay? The derivative of gx. That's if it's not just x. And really, you can always apply this rule because here that would be just the derivative of x. And what's the derivative of x? Just 1, right? So it doesn't change anything. So really, if you want to remember a hard and fast rule, remember that one, okay? So let's go through our first example. And you know what I'll do? I'll do this exact example using that rule there. So here's our f at x. Our base in this case, b is 5, okay? Our g at x in this case is equal to x. So according to what we've written out, oops, that wasn't very straight, but oh well. According to that, when we go to find the derivative of this function, we keep our original, which is 5 to the power of x. We multiply it by ln of the base, so I'm going to put the b in, and then multiply that by g prime x. Okay, so let's put these values in. Our b is 5, so we'll replace that with 5. And our g prime x in this case is 1. So we plug these values in. We'll end up at 5 to the power of x multiplied by ln base is 5 times a value of 1. 1 becomes negligible to us. We have 5 to the power of x multiplied by ln 5. And we could put ln 5 into our calculators. I got one here. 5 ln, ridiculous number. I'm not going to write it that way. So we're going to leave it as ln 5 multiplied by 5 to the power of x as our derivative. Our second function, using these same rules from above. So we know that f prime x will be equal to the original function. We'll call that b to the power of g at x. Okay, it's very upset. Multiplied by ln times b, b being our same base of 5, and then multiplied by the derivative of g at x. Now g at x in this case is equal to 3x minus 2. And we know our base is 5, so we'll replace b with 5. We want to find a derivative of g at x, so g prime x is equal to the value of just 3 in this case. So let's plug our values in now. Our original, which is 5 to the power of 3, power of x minus 2, multiplied by ln 5. And our derivative, which we worked out on the side, was 3. Okay? So when we write this, we might write it as 3 ln 5. So it's 3 times ln 5 multiplied by 5 to the power of 3x minus 2. And there's our derivative of our second function.